Hello students, greetings of the day. This is your Rao, faculty in physics from VIP classes. Today we'll have numericals and polarization. So before this, please go through once through part 1. Okay, what is polarization and all. Fine. Yeah. If the angle between the pass axis of polarizer and analyzer is 45 degree, okay, write the ratio of intensity of original and transmitted light after passing through the analyzer. Okay. Yeah. Thank you.
Polarized and analyzer is 45 degrees. You have to find out the ratio of intensity of original light and transmitted light. This is I. After it becomes I by 2. I by 2 depending on the angle transmits. IT is I naught cos square theta. I naught into cos 45 is 1 by 2. But I naught is I by 2. So I by 4. So IT by I is asking. I by IT is 4. Question down.
Here, intensity of transmitted light after passing through the first analyzer will be I naught by 2. Okay, so next intensity will be depends on the angle between the two pass axes. Keep in mind here.
Yeah, one more question down, right? 3 polarites are placed such that three polarites are placed such that three polarites are placed such that first and third are mutually perpendicular to each other. First and third are mutually perpendicular to each other. So three polarites are placed such that first and third are mutually perpendicular to each other. Unpolarized light of intensity unpolarized light of intensity I naught is incident. I naught is incident on first polarized. Unpolarized light of intensity I naught is incident on the first polarized. Okay, the intensity of light emerging from third polarized is the intensity of light emerging from third polarized is 1/16th of intensity of incident light. 1/16th of what? Intensity of incident light. Find the angle between first and second polarized. Find the angle between first and second polarized. Okay. So here we have two polarites. Here one more polarized is placed is same. Okay. So if I consider another polarized over here. So now see here. First polarized intensity of light is saying I naught. One more polarized we have here. Such that the pass axis. Okay. So three polarized are placed such that first and third are mutually perpendicular. Third is there. The third polarized is there, but how it is third polarized is perpendicular to their crossed polarized. Okay, so their path axis are perpendicular. So you can write down. This is path axis, for example. This is path axis of third polarized. Path axis is first polarized. First polarized axis. This is third polarized axis. These two are crossed polarized, 90 degrees. Okay. So you're saying if the intensity of light incidenting is I naught, so after this polarized, how much light will come in? I naught by 2 will come. After first polarized, but the intensity of light will come, half will become. And this I naught by 2 is falling on the second polaroid. So it is asking the angle between this polaroid and this polaroid. We don't know, let the angle be theta here. When this angle is here theta, okay, see here, first path axis is like this. Why? Because first polaroid axis is in this way. First polaroid axis and third polaroid axis, they are perpendicular. First one is like this, third one is this way. And if the angle between first and second is some theta, okay, you can write down this theta like this. Okay, when this is theta, so the angle between second polaroid and third will be how much, right? Hello, all of you. This is second polaroid. When angle between first and second is theta, first is okay, making some angle theta is the second one. This path axis angle is theta. First and third are perpendicular. So what is the angle made by this polaroid axis? Polaroid axis with this one, right? Third one how much? 90 minus theta. Yes or no? And then he's saying the intensity of light after passing through third polaroid is mentioning how much? 1/16th of incident light. This is 1/16th of incident light. That is I naught. Now find the angle between the polarities is asking. Question writing over, everyone. Question writing over. Try it now. Try it and answer fast. What is the answer?
Sir,
5 degrees, 90 degrees, 22.5 degrees, 60 degrees.
yes, sir.
Over. Hello. What is the answer, Rishi? Number, tell me.
22.9.
22.5 is coming. Yeah, right answer. Now, come on, tell how to do. Explain it. Now, intensity of light transmitted through second polaroid is equal to. But I naught value how much here? This is coming outside. Intensity is ready is I incidentally cos square theta. See, do one thing. You write intensity of light coming from each polaroid. Then you understand. Intensity of light coming after first polaroid is I naught cos square. I naught is incident. That is I naught cos square theta. But all ordinary light now, so this will be equal to I naught by 2. So you agree how much will be? After passing through first polarizer, all possible direction vibrations are there. Immediately it becomes I naught by 2. Now this I naught by 2 becomes incident light on the second polaroid. The transmitted light coming out of second polaroid. Okay, transmitted light after second polaroid is equal to incidenting on it. How much incidenting on it? I naught by 2 into cos square theta, where theta is angle between these two polaroid axes. Okay, this is second point. Next, third point is the intensity of light coming out of the third polaroid. So, intensity of light coming third polaroid is incident light. How much is incident here? How much light? This light is incident. Light transmitted from second polaroid will fall on the third polaroid. That becomes incident light. That becomes how much now here? I naught by 2 into cos square theta. This is I. Means I naught formula. I naught cos square theta. Cos square theta. Theta is angle between these two polaroid axes. This axis, this making theta angle. Now this is perpendicular. Third is perpendicular. This angle how much? 90 minus theta. This is cos square 90 minus theta. This is clear, everyone? All of you. So you can simplify I naught by 2 into cos square theta into cos of 90 minus sin theta. That is sin square theta. But this intensity, how much mentioned? 1/16th of incident intensity. That is 1/16th of I naught. I naught get cancelled. 2 ones are here, 2 8s are. So how much will you get right? Simplify it. How much will you have? So 2 8s are no. So here you can write sin square theta cos square theta no. So 1/8 is equal to you multiply with 4 and divide with 4 right? And you can write like this 2 sin theta cos theta whole square. Sin square theta cos square theta 4 dividing with 4. So sin 2 theta. This becomes 4 ones are 4 twos are. So 1/2 is equal to sin 2 theta whole square. So this implies sin 2 theta becomes 1/√2. So sine theta 1 for what value of theta? 45 degrees. So theta will be how much now? 45 by 2, that is 22.5 degrees. Therefore, the angle between the polarized axis of first one and the second one is how much? 22.5. But the angle between the second and third will be 90 minus 22.5. 90 minus 22.5. Understood, everyone? This is how, if the problem based on this particular polarized, if it is asked in Malus law, we should be able to do it. Okay, everyone? Make it fast. Yeah, next question. Over, everyone writing? Writing over, everyone. This question clear, Ray? Shall I go next question? Hello. One more question, change. A ray of light falls on transparent glass slab. A ray of light falls on a transparent glass slab. A ray of light falls on a transparent glass slab. This week's syllabus complete ray optics and wave optics. Ray. A ray of light falls on a transparent glass slab of refractive index. Glass slab of refractive index 1.62. If the reflected and refracted rays are, if the reflected and refracted rays are mutually perpendicular. Mutually perpendicular. What is the angle of refraction? What is the angle of refraction? Okay. Now, what to do you tell me now? Tan 1.62 is 58.3. Tan inverse of, you can say, tan inverse of 1.6 is equal to 58.3 degrees. And see, a ray of light falls on a transparent glass slab with some angle of incidence. This is a refracted light ray. This is a reflected light ray. Reflected ray, refracted ray. And you say these two are mutually perpendicular. This only happens when this angle is called what? Polarizing angle. Only happens what? When this angle is what? Polarizing angle. Already we have proved morning. If this is angle of reflection, I is equal to R, so I is equal to I. So this angle of refraction R then becomes this. I plus 90 plus R is 180 we have seen, isn't it? So I plus R is 90, R is 90 minus I. And here when it is reflected and reflected perpendicular, Snell's law we have applied. What you have seen? This angle is called polarizing angle. Yes or no? And from this what you have called? So this implies you have seen mu is equal to tan theta of P we have seen. Therefore, what is polarizing angle? Polarizing angle is equal to tan inverse of mu. This is equal to tan inverse of mu value how much given? 1.62. For this tan inverse of 1.62 value how much? 58.3 degrees. So this is this angle of incidence is called polarizing angle. And this is polarizing angle, I angle of incidence, angle of reflection also same. So what is the angle of refraction of it? So R value how much now? 90 minus I. 90 minus I is polarizing angle here, theta P. This becomes 90 minus 58.3 degrees. How much will get right? 60 is to 30. Means 29.7, huh? 31.7. How much will get? 10 means 59, 60, 90. Yeah, 31.7 degrees is what? Angle of refraction. So when they are mutually, so what you can say, this angle is polarizing angle, direct formula of refractive index polarizing angle relation mu is equal to tan theta P. Theta P is tan inverse of mu. For this value 58.3 is asking value of R. As you know, I plus 90 plus R is 180, R is 90 minus I. Subtract 31.7 degrees is what? Angle of refraction. Angle of what, sir? Refraction. Okay, everyone. This question will be based on these two laws, right? Also for you. So writing over everyone. Yes, all of you. For example, this plane wave is given, right? So this is the plane wave, the equation of polarized light is given by polarized light wave is given as, say for example, like this given. Ex is equal to E naught into sine kz minus omega t. So it is polarized in what direction? Dash. Yes, can you answer this question? Equation of the polarized light wave is given as Ex is equal to E naught sine kz minus omega t. This is traveling wave equation, no? So if you see here, so electric field, each head kz minus omega t, traveling what direction, right? If I take this as z direction, okay, this is x direction, this is y direction. So if you consider here planes, Ex E naught sine kz minus omega t is a traveling wave equation positive z direction. Direction of propagation is along z direction. Okay, and electric field vector what direction? It is oscillating in x direction. So electric field vector is oscillating parallel to x direction. Electric field vector is oscillating what? Parallel to x direction. So as electric field vector is oscillating always parallel to x direction, I can call it as x polarized light. X polarized light. And as this is z direction, propagation direction, x electric vector is what? Like this oscillating parallel to x axis. It is in which plane, right? It is in xy plane. So you can also call this one as x polarized light. You can say plane polarized light. Plane polarized light whose electric oscillations, whose electric vector oscillations are confined. Whose electric vector oscillations are confined in which plane? In xy plane. So you can call this as polarized in x direction, you can call or plane polarized. So x polarized light, why? Because electric field vector is oscillating in x direction. direction of proposed z direction. So perpendicular to this z plane is what? XY plane. So this is parallel to x axis lying in this plane. Lying in this plane. Electric field vector oscillations are lying in this plane. And lying in XY plane is also called plane polarized. XY plane polarized light. So who's okay? X polarized light or x polarized light? You can say x means linear it is. X direction is linear polarized. X you can say are linearly polarized. And whose oscillations are confined to XY plane. So plane polarized light. In which plane it is? Oscillations are confined. XY plane. XY plane is perpendicular to Z direction. Okay, so like this you can say is plane polarized or linearly polarized light. Plane polarized or what? Linearly polarized light. Okay, everyone. So till here, remember. So tomorrow we'll start. Okay, this with this polarization got over, right? Fine, all of you. So tomorrow new subtopic we'll take. Thank you all.
Thank you, sir.
Right. This question understood, everyone?
Yes, sir.
Right, right.